We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
I feel the liftoff. The clock has started. Roger.
This is a new and strange environment first. Just suddenly finding yourself in orbit.
We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
Hello and welcome. This is Michael Annis, and you're listening to episode 37 of the Space Rocket History Podcast. And now, Flight of Faith 7, Mercury-Atlas 9 with Gordon Cooper. The success of Mercury-Atlas 8 made the preparation for Mercury-Atlas 9 considerably easier, though it did cause some observers to suggest the Mercury program should be ended with Mercury-Atlas 8 in order to conclude on a clear note of success rather than risking another potentially catastrophic flight. However, this was not a view shared by the NASA planners, who had been pressing for a one-day Mercury mission since mid-1961, when it first began to seem technically feasible. Mercury-Atlas 9 was the fourth and final manned orbital flight of the Mercury program. The flight objectives were to 1. Evaluate the effects on an astronaut of approximately 1 day in orbital flight. 2. Verify that man can function for an extended period in space as a primary operating system of the spacecraft. And 3. Evaluate in a manned one-day mission the combined performance of the astronaut and a Mercury spacecraft specifically modified for the mission. In November of 1962, Gordon Cooper was chosen to pilot the Mercury-Atlas 9 mission with Alan Shepard as backup. Cooper named his spacecraft Faith 7. Cooper was born and raised in Shawnee, Oklahoma. He attended Shawnee High School and participated in football and track. During his senior year, his father, Leroy Gene Cooper, was called back into military service, and the family moved to Murray, Kentucky, where Gordon graduated from high school. He was active in the Boy Scouts of America and achieved the second highest rank of Life Scout. In 1945, Cooper turned down the possibility of a football scholarship to enlist in the U.S. Marine Corps, but he was too late to see combat in the Second World War. After completing 3 years of coursework at the University of Ohio, he received a U.S. Army commission. Cooper met his wife Trudy while in Hawaii, and they married in 1947. Here's a clip from NASA on Cooper.
The man who named his spacecraft Faith 7, for his faith and for his friends. The individual, Air Force Major and NASA astronaut Leroy Gordon Cooper, Jr. What events in his life led to his selection as the man who would take America's longest stride in space? He began flying at an early age. He soloed at 16. He became an Air Force lieutenant and jet pilot at 22. He also obtained an aeronautical engineering degree and qualified for the daring and methodical work of a test pilot. By the time he was selected as an astronaut, he was a trained, experienced test pilot of supersonic jets.
In September of 1962, NASA concluded negotiations with McDonnell to modify 4 Mercury spacecraft to a configuration that would support a one-day mission. This involved trimming as much onboard weight as possible to offset the additional consumables required. The changes made to the capsule hardware on Mercury-Atlas 8 were now used to justify the removal of 5.4 kilograms of control equipment, 2.3 kilograms of radio equipment, as well as the 34-kilogram periscope, which Wally Schirra found so unhelpful. A number of additions were made to the Mercury-Atlas 9 spacecraft to accommodate a one-day flight, Among these were the increased capacity of several life support system components, additional oxygen and water, and increased urine and condensate capacity, a larger capacity fuel tank and larger capacity batteries, and a slow scan television unit for in-flight evaluation and monitoring the astronaut and instruments. Building on Wally Schiral's photographic work, several other cameras were added as well. In total, there were 183 alterations listed between the capsules for Mercury 8 and Mercury 9 missions. Of course, weight and power limitations did restrict the amount of scientific experiments that could be scheduled. However, a number of in-flight experiments were planned for the Mercury 9 flight. They included 2 visual acquisition and perception studies, several photographic studies, 2 radiation packages, a tethered balloon experiment, a study of the behavior of fluids in zero gravity, and a micrometeorite study. A number of improvements were also made to the pressure suit worn by Cooper. These included a mechanical seal for the helmet, new gloves with an improved inner liner and link netting between the inner and outer fabrics at the wrist, and a torso section redesigned for increased mobility. The boots were also now integrated with the suit to provide increased comfort for long missions, to reduce weight and to decrease the time required to don the suit. Another change moved the life vest from the center of the chest to a pocket on the lower left leg, thus reducing the bulkiness from the suit and again providing more comfort during the flight. Because Mercury-Atlas 9 would orbit over nearly every part of the world from 32.5 degrees north to 32.5 degrees south, a total of 28 ships, 171 aircraft, and 18,000 servicemen were assigned to support the mission. And now the launch. Originally scheduled for launch in April, the mission was delayed twice. The first delay was due to a decision to rewire the Mercury-Atlas flight control system. The second attempt was on May 14th. On that day, when Cooper boarded Faith 7 at 6:36 a.m., he found a little gift that had been left for him. Alan Shepard, knowing that Cooper would have a new version of the urine containment device that Shepard did not have on his Mercury Redstone flight, had left behind a toilet plunger as a joke. Instructions on the handle said, "Remove before launch." The gift did not make the trip, and neither did Cooper that day. First, a problem developed with the fuel pump in the diesel engine used to retract the gantry from the launch vehicle. This resulted in a delay of roughly 129 minutes after countdown had already reached T-minus 60 minutes. Subsequent to the repairs on the gantry engine, however, a separate problem occurred. It was a failure of the computer converter at the Bermuda tracking station. This forced the cancellation of the launch at T-minus 13 minutes. The launch was rescheduled for the following day, May 15th. The countdown proceeded without a hitch until T-minus 11 minutes and 30 seconds when a problem developed in the guidance equipment, and a brief hold was called until it was resolved. Another hold was called at the T-minus 19 second mark to ascertain whether the system had gone into automatic sequencing as planned. Finally, at 8:04 a.m. Eastern Time, May 15, 1963, Faith 7 was launched from Launch Complex 14. Here's a clip of the news broadcast of the launch.
T-minus 1 minute and counting on the launch of astronaut L. Gordon Cooper.
Let's
go over to Mercury Control.
1 minute and counting. As of this time, all systems are go.
We just got the official word from Mercury Control. All systems are go at T-minus 45 seconds and counting. The loxing has been stopped. The vents are closed. The umbilical cord is ready to be disconnected. This is the big moment for the 36 5-year-old Air Force Major L. Gordon Cooper from Shawnee, Oklahoma.
This is Mercury Control.
We're down at T-minus 25 seconds.
30 seconds and counting. All systems are go at this time.
All
This is
systems
Mercury
are
Control.
go. We're coming up at 20 seconds. We're going to switch you over now to the Mercury Control for the final moments of the countdown.
This is Mercury Control. We have a momentary hold at T-minus 19 seconds.
This momentary hold at T-minus 19 seconds is not unusual.
T-minus 15 seconds.
We're
and
now
counting.
back counting.
Minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 3, 1. Ignition. Liftoff. At
4 miles.
4 after the hour. Liftoff.
30 miles an hour, 50 miles up, 60 miles an hour, beginning to roll on course. 132 tons, going up beautifully in a clear sky, straight as an arrow. 2,000 feet now, 200 miles an hour, the sound beginning to reach us now. He has started his second clock, and the sound is roaring over the Cape Canaveral here, straight into the sky. A beautiful launch as far as we can tell. He is at 5,000 feet, going 400 miles an hour, dead true up into the sky. 20,000 feet at this point, 600 miles an hour. He is approaching the sound barrier. He is at the point of maximum stress. The astronaut's body now weighs 1,125 pounds, 7.5 times gravity, way above us, traveling beautifully from what we can see, 40,000 feet, 1,240 miles an hour, 60 seconds. And now the contrail is beginning in what is a clear sky here at Cape Canaveral. He is arcing that long arc into course that's going to take him 500 miles over the Atlantic, over Bermuda, 100 miles, hopefully, up into the sky. We can see now only a final faint trace of the sustainer engine, but we can still see it against the sky. Now, here's Jay Barbary.
Now back inside, all is smooth here as we're approaching the booster cutoff portion of this flight. He has been airborne 1 minute, 45 seconds at this time. The Atlas Mercury rocket is programming, heading for that donut in the sky. Back over to Mercury Control.
The flight is now 1 minute and 55 seconds long. Astronaut Cooper reports his fuel system go, oxygen system go. His cabin pressure is at 6 pounds per square inch, and he reported that the sun was beginning to come into the window. This is Mercury Control, some 2 minutes into the MA-9 Fate 7 flight.
Coming up now on Pico, booster engine cutoff. There it is, right on schedule. Everything looks fine. It is normal at this time. The escape tower should be jettisoned in just a moment.
Pico, we call it here. This is Mercury Control, some 2 minutes and 30 seconds now into the MA-9 Fate 7 flight.
He is traveling now at 8,000 miles an hour, and he is 58 miles up. We expect him to jettison the escape tower now, somewhere in here.
Roger, this is Mercury Control. Our telemetry tells us that the escape tower has been jettisoned. Astronaut Cooper reports he is observed at leave, and we now have confirmation that the escape tower has been jettisoned. This is Mercury Control, some 2 minutes, 56 seconds into the flight.
90 miles up, his speed now 9,500 miles an hour, still being powered by his sustainer engine and apparently everything working
This is
well.
Mercury Control. Astronaut Gordon Cooper in his Fate 7 reports his fuel system go, his oxygen supply go. His cabin pressure has sealed off now at 5.6 pounds per square inch and is holding steady. This is Mercury Control, some 3 minutes and 20 seconds into the MA-9 Fate 7 flight.
At this point, he is 100 miles in the air. He is going 10,500 miles an hour and still increasing. He is almost level to that keyhole in the sky, which he'll need. Ground control must now give a go, no-go report.
Control. All of our indications here in Mercury Control tell us we have a go situation. He has been advised that we have a go situation here. We're now some 3 minutes and 45 seconds into the Fate 7 flight. Cooper reports all of his onboard systems are go, that his cabin pressure is holding steady, that all of the systems are operating properly. Our indications here are that the trajectory is A-OK at this time.
The liftoff ended up being excellent, with booster engine cut off and escape tower jettison exactly as planned. At about T plus 5 minutes, SECO occurred, sustainer engine cutoff.
Step camp green, SECO, I'm on off stamp. Going fly by wire. Everything is green there.
Faith 7 was inserted into low Earth orbit with a perigee of 161 kilometers and an apogee of 267 kilometers. The speed was 28,200 kilometers per hour, with a period of 88.5 minutes. After the spacecraft separated and turned around to orbit attitude, Cooper watched his Atlas booster lag behind and tumble for about 8 minutes. On his first orbit over Zanzibar, Cooper was informed that his orbital parameters were good enough for at least 20 orbits. As the spacecraft passed over Guaymas, Mexico, capsule communicator Gus Grissom told Cooper the ground computers said he was go for 7 orbits. Here's the clip.
We're giving a go for 7 orbits. Roger. For 30, how many? As many as you want. Roger.
On his second orbit, Cooper drifted off to sleep, thus becoming the first American to sleep in orbit. In fact, Cooper had also reported taking a short nap during the countdown phase. At the start of the third orbit, Cooper checked his list of 11 experiments that were on his schedule. His first task was to eject a 6-inch diameter sphere equipped with xenon strobe lights. This experiment was designed to test his ability to spot and track a flashing beacon in orbit. At T plus 3 hours 25 minutes, Cooper flipped the switch and heard and felt the beacon detach from the spacecraft. He tried to see the flashing light in the approaching dusk and on the night side pass, but failed to do so. Here's the clip.
And I am on fly-by-wire. I've armed the squib. Pitching up very, very slowly. And we'll deploy the flashing light minus 20 degree point. Flashing light is deployed.
On the fourth orbit, Cooper spotted the beacon and saw it pulsing. He reported to Scott Carpenter in Hawaii, quote, "I was with the little rascal all night," end quote. Cooper also spotted the beacon on his fifth and sixth orbits. On the sixth orbit, at about T plus 9 hours, Cooper set up cameras, adjusted the spacecraft attitude, and set switches to deploy a tethered balloon from the nose of the spacecraft. It was a 30-inch PET film balloon painted fluorescent orange, inflated with nitrogen and attached to a 100-foot nylon line from the antenna canister. A strain gauge in the antenna canister would measure differences in atmospheric drag between the 160-kilometer perigee and the 260-kilometer apogee. Cooper tried several times to eject the balloon, but unfortunately it failed to go. On the seventh orbit, Cooper passed Wally Schirra's orbital record as he was engaging in radiation experiments. After T plus 10 hours, the Zanzibar tracking station informed Cooper the flight was go for 17 orbits. During the 9th through the 13th orbit, Cooper was scheduled rest periods. First, he had a dinner of powdered roast beef mush and some water. He took pictures of Asia and reported the spacecraft condition. Cooper was not sleepy, and during Orbit 9 took some of the best photos made during his flight. He took pictures of the Tibetan highlands and of the Himalayas. Cooper slept intermittently the next 6 hours during Orbits 10 through 13. He woke from time to time and took more pictures, taped status reports, and kept adjusting the spacesuit temperature control, which kept getting too hot or too cold. On his 14th orbit, Cooper took an assessment of the spacecraft condition. The oxygen supply was sufficient. The peroxide fuel for attitude control was 69% in the automatic tank and 95% in the manual one. On the 15th orbit, Cooper spent most of his time calibrating equipment and synchronizing clocks. During his 22nd hour in space, a thankful Cooper recorded a personal prayer.
I would like to take this time to say a little prayer for all the people. Thank you for the privilege of being able to be in this position, be up in this wondrous place, and all these very startling, wondrous things that you've created. Be with all our families. Let them know that everything will be okay. We ask it in thy name. Amen.
When he entered night on the 16th orbit, Cooper pitched the spacecraft to slowly follow the plane of the ecliptic. Through the spacecraft window, he viewed the zodiacal light and the night airglow layer. He took pictures of these two dim light phenomena from Zanzibar across the Earth's night side to Canton Island. The pictures were later found to have been overexposed, but they still contained valuable data. Over Zanzibar, Cooper sent a message to African leaders that were holding a summit meeting.
Hello, Africa. This is astronaut Gordon Cooper speaking from Faith 7. I am right now over 100 miles above Africa, speaking to the Zanzibar station. Just a few minutes ago, I passed Addis Ababa. I want to wish success to your leaders there. Good luck to all of you in Africa.
At the start of the 17th orbit, while crossing Cape Canaveral, Florida, Cooper transmitted slow-scan black-and-white television pictures to Mercury Control. The pictures showed a ghostly image of the astronaut. In the murky picture, a helmet and hoses could be seen. It was the first time an American astronaut had sent back television images from space. Cooper took infrared weather photos and moon and Earth pictures as well. He also resumed Geiger counter measurement of the radiation. He sang during orbits 18 through 19 and marveled at the greenery of Earth. It was nearing 30 hours after liftoff. On the 19th orbit, the first malfunction occurred when the 0.05G light came on. The light, which was sensitive to changes in gravity, normally lit during re-entry. Cooper proceeded to check out the necessary attitude information, and all the telemetry indicated the spacecraft was in the correct orbit. It was therefore concluded that the light was erroneous. However, because of this, it was determined that the potential existed that not all of the automatic system for re-entry would function. Cooper was advised to use manual mode for re-entry. Here's the clip.
Hawaii Capcom, Phase 7.
Go ahead, 7. This is Hawaii. Read your line.
Oh, Roger. I wonder if you'd relay to the Cape the situation I had happen, see what they think on it. While turning my warning lights off and back on to dim, my 05G telelight came on in my telelight panel.
On the 20th orbit, Cooper lost all attitude readings. The 21st orbit saw a short circuit occur in the bus bar serving the 250-volt main inverter. This left the automatic stabilization and control system without electric power. John Glenn, on board the coastal Sentry Quebec near Kyushu, Japan, helped Cooper prepare a revised checklist for retrofire. Due to the system malfunctions, many of the steps would have to be done manually. Only Hawaii and Zanzibar were in radio range on this last orbit, but communications were good. Cooper noted that the carbon dioxide level was rising in the cabin and in his spacesuit. He told Carpenter as he passed over Zanzibar, quote, "Things are beginning to stack up a little," end quote. Throughout the problems, Cooper remained cool, calm, and collected. At the end of the 21st orbit, Cooper again contacted Glenn on the coastal Sentry Quebec. He reported the spacecraft was in retro attitude and holding manually. The checklist was complete. Glenn gave a 10-second countdown to retrofire.
10, 9, 8, 7, 6, squib arm, 4, 3, 2, 1, fire. Roger, a green on air. Roger, I think I got all three. Roger, how's your attitude, old Gordo? Well, pretty fair. Good show, boys. Real fine. They look like they came off right on the money on time. Roger, I think so.
During the manual re-entry, Cooper used his wristwatch to time the burn and his eyes to maintain attitude. In the recovery area, the crew of the USS Kearsarge spelled out Mercury 9 on the flight deck. Faith 7 landed just 6 kilometers from the Kearsarge, which was 130 kilometers southeast of Midway Island. Despite the lack of automatic controls, this was a very accurate landing. Splashdown was at 34 hours, 19 minutes, and 49 seconds after liftoff. The spacecraft tipped over in the water momentarily, then righted itself. Helicopters dropped rescue swimmers and relayed Cooper's request for permission to be hoisted aboard the Navy carrier. Permission was granted. 40 minutes later, the explosive hatch blew open on the deck of the Kearsarge, and Cooper stepped out of Faith 7 to a warm greeting. In total, Cooper traveled nearly 875,000 kilometers in 22 orbits. A few days later, May 21, 1963, President Kennedy presented the Distinguished Service Medal to Cooper. Here's the clip.
We're delighted to honor today the most recent of this very exclusive group, Major Cooper, who went furthest in space and did so on the anniversary of Charles Lindbergh's flight to Paris. I think one of the things which warmed us the most during this flight was the realization that however extraordinary computers may be, that we are still ahead of them, and that man is still the most extraordinary computer of all. His judgment, his nerve, and the lessons he can learn from experience still make him unique, and therefore make manned flight necessary, and not merely that of satellites. I hope that we will be encouraged to continue with this program. I know that a good many people say, why go to the moon? Just as many people said to Lindbergh, why go to Paris? Lindbergh said it's not so matter of logic as it is of feeling. I think that the United States has committed itself to this great adventure in the 60s. I think before the end of the 60s we will see a man to the moon, an American. And I think in so doing it's not merely that we're interested in making this particular journey, but we are interested in demonstrating a dominance of this new sea and making sure that in this new great adventurous period that the Americans are playing their great role as they have in the past. Most of all, we're very proud of Major Cooper and his family, and we're very proud that our country continues to produce these young men who go so far and carry with them so much. So, Major, we're glad to welcome you and your mother here, and your wife, with 2 children, and to tell you that you've given the United States a great day and a great lift.
I didn't really have much to say, and after that, all I can say is that it certainly is a great honor to be invited here and to be presented this award, and thank you all very much.
After the Mercury-Atlas 9 mission, there was a debate about whether to fly one more Mercury flight. It would have been Mercury-Atlas 10. It was proposed as a 3-day, 48-orbit mission to be flown by Alan Shepard in October of 1963. In the end, NASA officials decided it was time to move on to Project Gemini, and Mercury-Atlas 10 never flew. In conclusion, from a slow start with humiliating mistakes, the Mercury project became popular, and the manned flights were followed by millions on radio and TV, not only in the U.S., but also around the world. Apart from the manned missions, Mercury had a total of 20 unmanned missions. This also involved animals, most famously the chimpanzees Ham and Enos. Mercury laid the groundwork for Project Gemini and Apollo. The astronauts went under the name Mercury 7, and they each named their spacecraft with a 7 on the end. The Mercury program is estimated to have cost $1.71 billion and have involved the work of 2 million people. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.